All right, everybody, let's quickly solve problem 1 from the Async assignment. So in problem number 1, you have a platform, and on that platform you have a cannonballer. The platform is 12 meters high, and the cannonballer is shot horizontally with a speed of 15 meters per second in the horizontal direction. The cannonballer is going to go in a parabolic arc, land somewhere far away from where he was launched, and we're trying to figure out at first where to put the target so they land safely. Okay, so let's start by setting up a coordinate system. So I'm going to have positive b to the right and positive b up, and I'm going to call that little point there below my initial launch point, the most to the left and the most down, 0, 0. Okay. So the way I approach these is I like to make charts that help me organize my information. You don't have to do that, but I find it somewhat helpful. So I'm going to make a known and unknown chart for the horizontal direction, and I'm just going to put in the variables I know. I know my initial position is 0, even though I'm up high. As far as the x-axis is concerned here, I'm at location 0. X final is what I want. I don't know how long it's going to take me to get there. I know I'm moving at a speed of 15 meters per second. And remember, I don't need initial and final here because the horizontal speed is constant. And I know there's no acceleration in the x direction, which is just another way of saying that Vx doesn't change. So with all of that, I only have one equation that applies to the horizontal motion. The distance traveled, or the displacement, is equal to the rate times the time. Simplifying that with what I already know, I get that x final is 15 meters per second times the time, but I can't do anything with that without the time. And that's where I come over to the y. So let's look at our vertical motion now for a problem like this. Well, I know my y initial is 12 meters. My y final is 0. Even though I'm all the way down far away, as far as the vertical axis is concerned, y, I'm at height 0. My acceleration is negative g. I don't know the time. I don't know the velocity with which I'm impacting the ground vertically, and I don't need to worry about it either because it's not part of this problem. And I do know that initially, and this is very important, even though I'm moving sideways at 15 meters per second, I'm not moving up or down to start, so my initial vertical velocity is 0. Given that, the equation that's going to help us is equation 2 of the big 3. So let's plug in our numbers. 0 equals 12 meters, that's 0, plus 1/2 negative 9.8, t squared, and I get that t is 1.56 seconds. Now I can take that, plug it in over here for time, and I get that x final is 15 meters per second times 1.56 seconds, which gives me 23.4. So I need to place my target 23.4 meters away. So that's part A. Part B then asks us to do something different. It asks us to come in and intercept it somewhere over here and try to figure out how far over and how high up is the cannonballer after a time equal to 1 second. Let's figure that one out. Now, we could set up another known and unknown chart, but since we've already sort of laid it out, I think we can just, build off of what we have and articulate what variables have changed. So, to figure out the coordinates, the height and how far over and how far up, we can start with the x. So let's start with the horizontal motion. We know, just like over here, that x final minus x initial is the Vx times the t. Well, x final is still what I want. X initial is still 0. My horizontal velocity hasn't changed from before. I'm still moving forward at 15 meters per second, but now my time is 1 second. And so x final is 15 meters. So I'm 15 meters over. Now let's do the vertical. And again, we're going to use the equation of position for the vertical motion. Y final equals y initial plus v initial yt plus 1/2 at squared. Y final is what we want. y initial starts still at 12 meters. There's still no initial vertical velocity at the start, and then plus 1/2 times negative 9.8 meters per second squared times 1 second squared, and we get that y final is 7.1 meters. So what that tells us is that our little guy is 15 meters over and 7.1 meters up after 1 second. Now, the last part of this problem asks you to do something different still, and that is to figure out not where it is at 1 second, but how fast and in what direction it's moving. So let's come back over here and let's draw on this picture the way it's going. It's kind of moving at that moment down and to the right if I were to represent its instantaneous velocity at that spot. And what you can see, if you look closely, is that down and to the right velocity is really made up of a rightwards component and a downwards component. And our job is to figure out both of those components and then combine them to get the total speed and also the total angle, so we can specify not only how fast it's moving, but also the direction. I'm going to draw that a little bit bigger over here. So here's a dot representing the cannonballer at that moment. Here's the cannonballer moving to the right, and you might already realize that's the horizontal velocity at that moment, which hasn't changed from 15 meters per second because it never changes in projectile motion. The horizontal velocity is constant. We have a downwards component that wasn't there at the start. That's the final y velocity. It's the vertical velocity, which at that moment is down. And then we have the resultant or total velocity, v, which we're going to have to combine using the Pythagorean theorem. And we have the angle that they make. And when we say what's the velocity, we mean what's the speed and what's the angle. That's what we want to figure out. We already have some of the work done for us. We know that Vx is still 15 meters per second. So this just really amounts to figuring out how much vertical velocity has this cannonballer grown over that 1 second of falling. And again, we can stick with our big 3 and use equation 1 this time because we want velocity information and we don't really care about position. We're just talking about velocities and times. So Vy final equals Vy initial plus At. Vy final is what we want. Vy initial is still 0. It's still at the very beginning, not moving up or down. Plus A, which is negative 9.8 meters per second squared, times t is 1 second. And you quickly see that the final vertical velocity at that moment is negative 9.8 meters per second. Now, I want to combine them to get the total v. And I'm going to do that using the Pythagorean theorem. I'm going to do 9.8 squared plus 15 squared equals v squared. And if I do that, I'm going to do it down here. 9.8 squared plus 15 squared equals v squared. I get that my total speed is 17.9 meters per second. Now I'm not done. I said how fast it's going, but I have to specify the direction. That's where I'm going to use this angle. And the function that's probably the most direct is the tangent function, where I can use the opposite over the adjacent. So let me do that. Tan theta equals, now when you're doing the trig functions, you don't use the signs because you're really just talking about lengths of sides. So that's where you can ignore the signs because we're just doing ratios. So tan theta is 9.8 over 15, and theta then would be the inverse tan of 9.8 over 15, which comes out to be about 33 degrees. So at 1 second, my cannonballer is moving with a speed of 17.9 meters per second down at that angle, at an angle of 33 degrees. That's it. I hope you got things close to those answers. If you didn't, hopefully this video helped you figure out where you went wrong, and on to the next one.